actually in the screen?
Yep, you're right in the bullseye middle. And it's recording. I don't know why.
Why?
Because you're not smiling.
Well, I'm not ready to shoot yet. All right, welcome back, all you FGers. Hey, you see, I got one of my real old shirts out of storage here. I've got a shirt here, which is probably a little beat up, seen better days, but honestly, this shirt is probably older than some of the people that are watching this video. This is a Dale Earnhardt Goodwrench Racing shirt from the late 1990s, and I don't really get rid of things very often. I like to hold on to stuff, as you can probably tell by this perfect example. Just felt like yanking this out of the closet and giving a little tribute. So that's what you're going to see today. So this is wiring 103. If you caught the first one, I talked about soldering and crimping, which was several months ago. Here we are just about 2 weeks from wiring 102, which I had posted, and I had talked about measuring voltage and current in there, but didn't really get into that detail, and so I decided to make a third video, and I am now using two cameras here. As you can see, I'm going to cut between views because as I was editing the last one, I realized that you could see the table over here and my hands over here, and when I was lifting up pieces of wire to display them, well, they kind of just disappeared up into the ether and then came back down again. And I realized how poor that really looked, honestly, on playback. I was kind of really disappointed about how everything came out. So I decided that it was definitely time to look through the equipment that I had and see what I could do about improving that situation. So here we are today. So anyway, without further ado, let me get started. So we were talking about AC and DC current, and also about voltage. So let's look at current first. So if you look at this gadget over here, this is a test unit that actually my brother had picked up one of these on eBay, and I found out that there is a company in Baltimore, which is not too far from where I live, that sells all sorts of electronic equipment, and once upon a time one of these just happened to come up for sale, and this is exactly the same unit that he had. And I was pretty excited about that and put in a bid, and I won. So I brought this home. So this is a stabilized voltage and current supply unit, which can basically be controlled, somewhat programmed by these buttons here in the front, which can change its functions to running in parallel, in series, or independently for two different voltage systems. So first of all, I'm going to show you how to measure DC current, which we had talked about. So I'm going to go ahead and turn this on. And you see there that it's showing that it's not supplying any amperage right now. So I was able to acquire this unit from that electronics clearinghouse in Baltimore City, and got it at a pretty decent price. So I went ahead and jumped on it and knew that it would be probably handy in the future. It's not a super high current capable machine, so you can't really test car amplifiers or anything big like that, but it can power up electronics and smaller loads like illumination type of light bulb. Speaking of light bulbs, that turned out to be a funny project in itself, being that pretty much everything is LED these days. Trying to find something that would actually display a reasonable amount of current draw turned out to be more of a challenge than I had expected. So I actually went rummaging around in the garage and resurrected a lamp assembly from my weekend toy, my old Pontiac. I found a new one of these, brand new NOS in a box, which is really beautiful. All the paint that's supposed to be on this emblem is in place, and it looks really, really nice. And of course the plastic is clear and not all hazy looking like this. So this is the old one, but it does still have one of the bulbs in place. So if you look on here, you'll see the amperage is reading, well, this one says 0.1, this one says 0.0. It's not supplying anything. It's outputting 13 point, well, you can see it's bouncing between 13.2 and 13.3 volts. And this is voltage following is illuminated here. This would be current control, and currently we are on voltage control because obviously I want to keep the voltage from spiking too high, so this is where we're running. So if you watch, remember what I had said earlier, that the lead from the multimeter, here's the red one, right, goes over to here. Okay, and here's the red lead from the load, which as I had said, the multimeter has to go in the line with the black lead feeding the load. So I do this, and the load turns on. Bingo. So now if you look at the multimeter, I'll turn that around and show you. It's showing 3.26 amperes, which for a fog lamp is probably pretty accurate. It's about 35 to 37 watts, maybe 40, which is pretty much expected for an incandescent lamp of this size. So there you have a DC test. And I'm going to go ahead and turn that off. And I'm going to come back over here and we're going to go now to an AC test. If you remember in 102, I described how AC voltage is the Loch Ness Monster, a wave. It's not a continuous steady voltage. It varies constantly. It never is the same. It does that 60 times a second. We use 60 hertz single phase electricity in a home, and most industrial machinery is usually either 240 single phase or 480 volt three phase. Basically your same scenario. So remember we had talked about the green and the clamp. All right, so here we have a special test harness that I've constructed, which I plugged into a power supply that is going to a laptop. So I'm going to fire that up. Okay, I have the laptop running, and there we are. All right, now you're probably wondering why I have to do all this butchery. Why can't I just go like this? Okay, well, let's analyze what's actually happening here. Voltage, whether it's AC or DC, always flows in a complete loop. You have your power supply that's starting. Voltage goes out, goes around, goes through the load, whatever that happens to be, and comes back to ground. Or in AC electricity, it goes from the hot side, in 120 volt, it's the black wire, the hot leg, comes back to the white leg, neutral. 12 volt, it's red is your hot side, black is your ground. So, given that it's going in a loop, if you have a wire like this, well, you've got all three of your conductors right here, right? So if you take and put a clamp on here like this, well, what's going to happen? Well, glad you asked. Let me turn it on and zero it, and you'll see that the answer to that question is actually nothing happens. Now, so it's reading all zeros, right? Because current's flowing in one direction, it's looping through the load and coming back, it's flowing back through the other direction. So you've nulled out your reading because current through one end must be the same as current coming back through the other end. So you've got nothing. Well, all right, this is reading 0.3, which is just spurious, right? Okay, now if I come over here and I clamp it around one of the leads, now you watch the meter. It's now beginning to climb. You can see that it is at 0.23, or about a quarter of an ampere. Now, this is just a laptop, obviously with a standard LCD screen, so they don't draw a whole lot of power when they're basically idling. They're parked. So I'm going to run a stress test on here, which pushes the CPU and other things like that into a much higher mode. Now I hear the fan spinning up already, and you can see that the reading now is changing to about 1.25 amperes. Now it's beginning to drop because the next layer of the stress test is starting, which is not drawing as much power. So that shows you that even with a computer like this one, this is just a MSI gaming laptop, belongs to the company, nothing particularly special about it. Its current draw is not steady. It'll vary practically second by second, depending on what you have it doing. So if I go ahead and pop the clamp off again, you'll see the numbers begin to drop. Until they've dropped back to just about 0. Most often you won't get an exact 0 reading. That's just the nature of these beasts. Now, let me go ahead and put this around the ground lead, third cable here, which is the yellow and green. You notice that absolutely nothing is happening. Why would that be? Well, that is because there should not be any current flowing through this. This is simply a safety lead. Your black and your white are carrying the current. This is just in case of an equipment malfunction. This goes from the metal casing, or the metal chassis in the case of a laptop here, or actually the power supply, honestly, back to earth ground, as does this white, at the circuit breaker box over in, well, wherever mine happens to be located in the garage, but wherever yours is, and that's how that works. So again, let me snap that back on there. All right, so you see that I got 0.3. Let me come back on there again. And we can see that number's now changing. And if I stop, and restart the test, should see that number again bounce up to somewhere from 0.5 ampere to 1 point something or other, and go from there. So that concludes the AC and DC amperage testing, and very quickly I will give you a view on voltage testing. So if you noticed that before, when I had pointed out how we were testing for amperage, we had to put the machinery in line. This is just a voltage sensing switch, in case you happen to be curious. This is a neat little piece too. Picked this up off of Amazon for $25. It's all solid state. It can handle up to 30 amperes at 12 volts. And what you do here is you connect the battery as it's shown right here. Very easy to figure this one out, plus and minus, very clearly marked. The load goes over here on this side, which is what I had this connected to. And if the voltage drops below 12.1 volts, it will disconnect the load. So you could connect this to, I don't know, anything, a small portable refrigerator, a little radio, television, anything like that that you might have while you're camping, to protect your truck battery from being drawn down so far low that it doesn't have sufficient voltage to and amperage capacity to be able to restart your engine. So these are really handy. I haven't figured out exactly where I'm going to attach this to yet, but I've been playing with it, so it turned out to be pretty neat. So anyway, voltage demonstration. I'm going to turn the power supply back on again. There we go, and you can see the light turns green, which means that it's passing power to the load, although there's no load on it right now. And so to do a voltage test, instead of going in line like we did before, now we're going across the load. So simply observing colors, we just put our voltmeter right on there, and if you see on the screen, alright, let me hold that up. So you see on there it's displaying 13.3 at no amperes on the power supply unit itself, and it only reads out to 3 digits. This one reads out 4, so it's showing 13.37. So that is telling me that the tracking between these two is pretty accurate, and I would have confidence in either of these reading correctly. So that's your voltage measurement for any device you need to take a look at, especially if you have something that isn't functioning correctly or has quit functioning at all. This is a real easy test to take a look, even say for a blown fuse. You just take the leads, this goes to the battery or the power load supply side and your ground, and then take a look at your reading. If it's still zeros, well then you know that you've got a broken wire, bad switch, bad relay, something has interrupted your current flow and your voltage. Other than that, if it checks out okay, well then most likely whatever it is that you are working with probably has failed. Radio, light bulb, I mean, it could be anything. How many parts are in a Frontier that are electrical? You name it, it's there. That's where you're going to be going from next. Most sensors run 5 volts instead of 12. They're TTL logic. So you would do the same thing. You would want to run these two across the sensor plus and minus feeds, and then take a look and see if that's hot. Then usually there's only 3 most of the time. You've got a plus, you've got a minus, and then the center lead, like I said, it's usually only 3, is your signal back to whatever controller that sensor is reporting to. That's what you need to look at next if you're suspecting a failed sensor. But that can get real dicey because some sensors are digital. So if you just try to look at it and find a voltage with one of these, it's probably not going to report correctly, or it may not report anything at all. That gets a lot more complicated. I honestly don't even really probably have the test equipment here to demonstrate in a video how to go that far. That's probably where you end up taking it to a shop or over to the dealer for them to attach the Nissan Consult. It's like a $17,000 computer to your truck to find out what ails it. Club Frontier, which I'm a member, is a great resource for lots and lots of things related to anything going on in Frontierland. by itself specifically. And then there's another website called Nico Club, NICOCLUB, Nico Club. They have the complete service manual up to, I think, 2016, I believe, for the Nissan Frontiers to be downloaded for free. My truck's a 14, but I've used that manual for a ton of projects, and I would say, off the top of my head, I can't think of anything that didn't match. Other than the stereo system, which I think changed a little bit during some years, the truck really has not been altered from 2005 until 2019. I think it was 2020 it got the 3.8 liter with the 9-speed Mercedes-Benz derived transmission. So that you'll probably find some wiring differences definitely in the PCM circuits and the transmission controller. But other than that, the body wiring is pretty much all the same. BCM, the IPDM ER, the fuse blocks under the hood, fuse blocks inside over on the passenger side. The locations and outputs for those are all pretty much the same. So those are excellent resources if you're deciding to make any modifications to your truck and you just really need specific pin numbers, which has been super great in the projects that I've been doing, or if you just need to get more of a general idea, you're not quite so familiar with electricity, electronics, just kind of getting started, getting your feet wet, so to speak, and you really want to see how things are constructed and how they work. That manual is awesome. Not only does it have troubleshooting tips and steps that you can perform basically just with a simple meter like this, things of this nature, but it also talks a lot about the console system as well, which I'd mentioned is basically a dealer only, unless you were an extremely wealthy truck owner and decide to go buy one of those for your own use. It would be wonderful to have one, but they are very pricey. But they can be a real lifesaver when something really funky is going on. So in those particular cases, you might be lucky enough to find an independent foreign vehicle dealer or foreign vehicle servicing shop that has one of those that they paid for and actually brought in for use on Nissans. Otherwise you'll end up with the dealer, but still, either way, at least you'll have a very good idea starting out of where you're going, which will enable you to, let's be honest, some dealers are kind of, they're they can be quirky. If they feel like they can make extra money by adding tests and padding parts that really don't need, some of the ones that are really not so reputable will do that to you. And at least this gives you a good baseline on where to start, that maybe you can go in there and, armed with a little knowledge, say, I think A, B, and C that you're telling me is probably correct, and okay, I approve these parts and this repair, but this other stuff, nah, it's not making sense. You might be able to save yourself some money that way. So really hope that all of this has been helpful. I hope it was clear. Leave comments, please. If it was helpful, please let me know. If it wasn't helpful, well, hey, let me know about that too. And if this assists you in a project and you're like, hey, I didn't know how to get started, and your video got me over to where I needed to go and how to progress, hey, please let me know about that too. I love to hear about anybody's victories. It's not about me with ego or anybody else with ego. It's all of us as a team. It's our joint love of the Nissan pickup. The Tacomas get all the parts and all the love. Everybody talks about them. You see them on TV, and they've got an aftermarket that's 10 times our size. So we're just the little fringe guys, off in the corner that have to fight for the scraps. So let's stay together and stay solid. We're a team, so let's move forward as a team. I hope this has been helpful. Until next time, Frontier Geek signing out. Take her out, get her muddy.